Hello. Let's continue from where we left off. In this video, I will show you how to modify the model geometry. Let's go back to the data input and see how we can change the model geometry. If we want to make a change in the geometry, for example to edit the areas, we switch to selection mode on the left. From the list, I select the Select Area Points option. Then I click the Select button. Now I select one of the points here. As soon as I select it, its coordinates are displayed on the screen. For example, let's move this point 1 or 2 meters upward. As you can see, the y-coordinate has changed. Let's move the other point upward as well. This way, we have modified the model geometry. Now, when we click the Analysis button and return to the analysis, we can see that the geometry has changed, and a message appears saying, "Please re-enter the slip surface." This is because when the geometry changes, the slip surface must be defined again. Now I define the slip surface again. I click the button, then select the center point. I set the radius. I click OK, and the slip surface is created. When I run the analysis again, we can see that the factor of safety is 1.22. Because we reduced the slope height. Now we move the coordinates upward, so let's also try the Bishop method. With the Bishop method, we obtain a similar result. To view the report, we can click the Report button and open the report. Now I return to the data input again. This time, let's see how to add the groundwater level. We have two buttons for this. One lets you define the water level by entering coordinates. The other lets you define it interactively. Now I click the related button. I select the first point of the groundwater level. Then I move to the second point. You can define as many points as you want. For example, I add a third point as well. After defining the last point, I right-click to create the groundwater level. Now when I go back to the analysis, we need to re-enter the slip surface because the geometry has changed. I define the slip surface again by selecting the center point and the radius, and creating the surface. With the Bishop method selected, I run the analysis, and we can see that the factor of safety has decreased. After defining the groundwater level, I return to the data input to add surcharge loads. Now let's look at how loads are defined. Here, there is a list where we can select the load type, and I choose a load type from this list. For example, I select strip load. To add the load, I can enter coordinates or define it interactively on the screen. Now I will add it interactively on the screen. For this, I first click the Object Snap button. Then I click the Interactive Surcharge button and select the point. When I click, a window opens where I can enter the load properties. The load is named Surcharge 1. You can change it, but I will keep it as it is. I don't change the coordinates here. Let's set the load width to 10 meters. And I enter the pressure as 250 kilonewtons per square meter. I click the Add button. As you can see, the surcharge load has been added to the model. Now I go back to the analysis, activate the analysis section, and we can see that the slip surface is preserved. Because we did not change the geometry, the slip surface remains the same. I click the Run Analysis button. As you can see, due to the surcharge load, the factor of safety has decreased slightly. In this way, we can add surcharge loads and observe their effect on the factor of safety. You can also place the loads geometrically near the crest or near the toe of the slope. Now let's change the surcharge load value. In selection mode, I select the Select Surcharge option from the list. Then I click the Select button, double-click the load, and open the Load Properties window. Here, I reduce the load value to 100 kilonewtons per square meter. I click the Apply button. Then I right-click. As you can see, we changed the load value to 100 kilonewtons per square meter. Now I click the Analysis button again. With the Bishop method selected, I run the analysis again. As you can see, since the load is reduced, the factor of safety increases slightly. In the next video, we will continue with anchors.